Hi, good day. My name is Adeleke-Adedoyin. I'm a cloud solution architect for Microsoft. Today, we're going to complete the third and final video of our Azure DevOps demo, any developer, any language. In our previous demo, we got source code from GitHub and put it in an Azure repo. We then created an Azure pipelines using container tools, Helm, and Docker to push it to an Azure ACR. In this episode, we're going to focus on using Azure pipelines to deploy all four languages to our Azure container cluster. It's easy to kick off a new release template by creating a blank template for our dev stage environment. In this pipeline, in every pipeline, we need to also make sure that we have our artifacts coming from the correct source. Adding an artifact for this case will be our parrot build artifact, making sure that we get that input and tie it into this release pipeline deployment. Typically, every pipeline has a set of tasks used to accomplish a release. For this release, we'll make sure we have our open source tools such as Helm, package and deploy with Helm charts, and a bash shell script that we'll use also. Moving over to our release pipeline variables section, we'll put in the same variable pipelines that we have in our build pipeline definition. Project name, registry login, registry password. We can grab this value from our previous build pipeline and key them in. It's the same target. What we're making sure here is that we have release variables that are set up so that when we do automate releases, we can use this release variables to access our AKS cluster and our Azure Container Registry. Moving over to our task section, we want to make sure that we set up our release steps. We're going to use Helm, which is a container native open source tool used to manage any Kubernetes cluster. In this case, we're targeting an Azure Kubernetes Service cluster. There are two aspects to Helm setup, a client side and a server side or tiller side. The tiller side is sometimes called the backend. So here we'll make sure that we set up the backend with the init and the service account tiller. In the bash script here, we'll make sure that we're setting up the Helm add repo, which adds the chart and which is the scope for actually defining the release. Finally, we'll use the Helm upgrade command on the target Azure Kubernetes Service cluster. We want to make sure we target the right namespace because we're potentially going to install other container and line of businesses on the same cluster. So we target it with the right namespace. As mentioned previously, the chart is what actually describes and sets up the release, the deployment. So charts are very crucial, and we make sure that we have that right. And we will also set the version number, making sure that we pull the right repository from our ACR or Azure Container Registry. That's important. Other things like setting our tags, image tags, is also important. We're doing really well here. We're coming to the end of setting up this release step, but we can see in the big picture that there are a lot of moving parts, and sequence matter and consistency matter. With Azure DevOps services, we're able to connect all of these pieces together, connecting our cluster with our Azure Container Registry and setting the right commands to manage the upgrade. We can go ahead and queue this release and have no worries. We can queue it for our .NET Parrot. Very quickly, because it's a consistent way of releasing to an environment, we can pretty much clone this existing setup and target it or reposition it for our other line of business application, specifically for our Captain Cube, which is our Go line of business, making special attention to make sure that we have the right input into the release, which will be our Captain Cube build. We'll set up the right variables for the project name, Captain Cube. And there we have it. We'll do the same clone setup and make sure that we have our auto friend setup. In this case would be our node. It's really that simple. We'll make sure that we finish the same customization for our Node project, then save and kick off a release for Node Brady, which is our JavaScript application. Same thing is done for Fifi, which is our PHP application. The pattern becomes really obvious, and it's really simple. We now have a consistent way to deploy things to Azure Kubernetes cluster. All our 4 friends have been deployed. Let's take a deeper look into what we've done. We can go into the portal in the Cloud Shell and use the AKS get credential command specifying the cluster and the resource group. Merging context, we can use kubectl to get nodes. Specifically, we want to get all containers in our namespace Fifi and friends. Remember, the cluster can be used to deploy any application. In this case, we deployed Fifi and friends. A little typo there. I'll redo that again. The external IP address shows the ingress point for our containers. You can see all our containers have been deployed successfully. Let's navigate to that to verify. Typing in that IP address, we indeed see all our friends: Parrot, Captain Cube, Fifi, and Node. That's 4 different languages deployed with Azure DevOps. So we're finally at the end of this demo. What did we do? We brought in code into Azure repo, and we used Azure build pipelines to build things to Azure Container Registry. We also used our release pipeline to build 4 different languages as containers. Thank you.